Okay, I just want to go through this review and show you guys how to do each of these problems. All right, here we go. So, number one, what I would do is go through and, since they're both inside the square root, they're both in quarantine, they can both hang out. So, we can go through 3 times 15 is equal to 45. And then, just like with fractions, we have to make sure that we simplify. So, we got to look and figure out which perfect square can we divide 45 by. Ends up being 5 and 9, square root, square root. Since we can take the square root of 9, we can get 3. The square root of 5 is left over, so that one's just going to have to go right next to it. 3 square root of 5 is our final answer. Number 2, super similar. You 3 times 7, we get 21. All of them, then we have to check, just like the other one, to see if there's a perfect square that goes into 21. 9, 16, no. So we just leave it like that. Looking at number 3, it's multiplication in between these two. So that means we can go through and distribute the square, right? Multiplication's nice like that. We can just do those easier steps. So then we'll have 2 squared times the square root of 10 squared. Making sure it's multiplication in between, not addition. 2 to the second power is 4. The square root of 10 squared, well, the square root goes away and we're just left with 10. So that looks like 40. It's going to be our final answer. Scrolling down, look at number 5. Whenever you see parentheses and you have a sign in between, like 4 and 5, then we're going to have to distribute the number through. So I'm going to distribute this 5, and the 5 isn't in a square root, right? It's not in quarantine, so it can't combine with those other ones. So we're just left with 5 square root of 3 minus 5 square root of 5. We can't put these together because they're not like terms, right? The square roots have to be exactly the same in order for you to put them together with subtraction. Number 5, square root of 3 times 2, they can't hang out, so they just get squished next to each other. Then square root of 3 and square root of 5 can hang out, so we're just left with square root of 15. Pausing, thinking about if we can simplify. Can't divide 15 by 9 or 4, so that's as simplified as it can get. Number 6, keep it on. This one's different. You have parentheses, so your gut's going to tell you that you have to distribute or you have to use the box method, but it's all just multiplication. So you can go through and combine your values by multiplying, making sure we're not cross-contaminating, right? If they're in quarantine, they stay in quarantine. If they're not in quarantine, they stay out of quarantine. So I got negative 2 times 7, which is negative 14. Then we can do square root of 6 times square root of 3, which is square root of 18. Pause. Can we simplify? In this case, we can. 18 gets split up into not 3 and 6, but 2 and 9. So I'm going to take the square root, take the square root. The one that breaks out of the square root, that 9, we're going to get 3. Square root of 2 is left over. Don't forget about that negative 14. We have to multiply that with it. So negative 14 times 3. Oh, geez. Testing my mental math right now. 14, 28. 34. Oh my God. This is embarrassing, guys. Okay, it is 42. It's 42. Negative 42. Negative 42 square root of 2. Final answer. Moving on. When you see that you have it squared and there's that minus sign in between, you got to do the box method. So when we're doing the box, all right, we got square root of 6, negative square root of 3, and then that same thing's going to go on the side. Square root of 6, negative square root of 3. Multiply to get what's inside each box. So I got square root of 6 times square root of 6. Square root goes away. We're just left with 6. Square root of 6 times square root of 3. Well, negative square root of 3, so we're going to get negative square root of 18. Same thing right here. We get negative square root of 18. And then lastly, you've got square root of 3 times square root of 3. Negative times a negative makes a positive. So left with positive 3. To combine these, we're going to look at our like terms, remembering to add them across. negative 19 plus negative square root of 18 plus negative square root of 18, and 6 plus 3. So that is 9 minus 2 square root of 18. And we know we can simplify 18 because we just did it up above. It can get split up into square root of 2 and square root of 9. So 9 minus 2, square root of 9 becomes 3. Make sure you're multiplying it with that number that's on the outside. Square root of 2 is left over. 9 minus 6 square root of 2. You cannot put these together. Don't simplify too much because they're not like terms, right? They don't both have a square root of 2. All right. Number 8. Okay, we know we got the box method because I got two things that we can fill in here. First one I like to put up top, 4 negative 2 root 5, and then we got 4 positive 2 root 5. Multiplying to get the numbers on the inside, 4 times 4 is 16. Negative 2 and 4 are the ones that can hang out here. So negative 2 times 4 is negative 8, square root of 5. 4 times 2 gives us 8 square root of 5s. And then this last part, the 2's can hang out. So negative 4. And then square root of 5 times square root of 5, well, those square roots cancel and you're just left with 5. So make sure you multiply it there with that 4. So this number right here is going to be negative 20. That's what I'm going to combine with that 16. So I go through and I'm looking at my like terms. On this diagonal, when I add negative 8 plus 8, we get 0. So you know what? That means it goes goodbye, eliminated. But got 16 minus 20, right? Because that's negative 20. So negative 4 ends up being your answer. All right, one last box method before we move on. We've got another squared one. This time we got 3 square root of 11 minus 4, 3 square root of 11 minus 4. Right? You write it twice because that square there can't distribute the square because of the minus sign. So first box, the 3's can hang out. 3 times 3, you get 9. Square root of 11 times square root of 11, well, you're just left with 11. Making sure you multiply both of those together once the 11 breaks out of the square root. Negative 4 times 3, because those ones are both outside the square root, you get negative 12. Square root of 11 is left over. 3 times negative 4, you get negative 12. Square root of 11 gets squished next to it. Last, we got negative 4 times negative 4, so we got 16. Going through and combining our like terms, right? Keeping in mind that that piece right there is 99. So combining on our diagonal, 99 plus 16 is 115. Yep, I'm going with it. 115. Then negative 12 square root of 11 plus negative 12 square root of 11 is negative 24 square root of 11. Since they have the same sign here, they're not going to cancel like the last one. Boom, final answer. Can't combine them. All right, on to rationalizing the denominator. Whew. In order to rationalize the denominator, what you're going to have to do is multiply by the square root that's in the denominator. So square root of 10, square root of 10, have to multiply on the top and the bottom. Make sure it's inside the square root. So then the square roots can hang out right there. You got square root of 50. And then square root of 10 times square root of 10 is just 10. Don't stop. Make sure you simplify if you can. 50. Remember, anytime you see 25, 50, 75, quarters. Takes 2 quarters to make 50. Square root, square root. All right, well, square root of 25 is 5. Square root of 2 is left over. And you're left with 10 on the bottom. Not done yet. This one's tricky. We can take out a 5. We can divide by 5 on top. Divide by 5 on the bottom. And we're left with 1, but you don't have to write it. Square root of 2 over 5. All right, same thing for the next one. Square root of 2, square root of 2. 2 on the bottom. Those two can't hang out, so you get negative 2 root 2. Make sure you're simplifying your fraction. Since both of these 2's are outside the square root, we can cancel them out. And we're just left with negative square root of 2 for our final answer for number 11. All right, moving on. Square root of 6. Square root of 6. In this case, all of them can hang out. Square root of 6 times square root of 6. The 6 breaks out. Square root of 8 times square root of 6 is square root of 48. Making sure we're going through and simplifying if we can. In this case, 48 can break up into 3 and 16. Square root of 16 is 4. Square root of 3 is left over 6. In this case, we can divide by 2 on top, divide by 2 on the bottom, and we're left with 2. Square root of 3 over 3. You cannot cancel those 3's because the one on top is locked inside the square root. Square root of 5. Square root of 5. Same drill. Square root of 5 times square root of 5. 5 breaks out. Negative 2. 75? Yes. Yeah. So we got square root of 75 because the 15 and the 5 can hang out and multiply them together. Break up 75. Always think about quarters. 25 and 2. Square root of 25 is 5. Square root of 2 is left over. Don't forget about this 2 that was in front. We have to multiply it over 5. Since there's a 5 being multiplied on top and we're dividing by 5, we can go ahead and cancel these ones out. So then we're just left with negative 2 times square root of 2. Box it up. Biggest thing when you're rationalizing the denominator, it doesn't get the square roots away completely out of the entire thing, just out of the denominator. So square root of 90, I'm going to simplify. I'm breaking up into 9 and 10. Square root of 9 is 3. Square root of 10 left over 5. And with that 3 and that 5, they don't have a common factor, so that's just our final answer. When I'm looking at number 15, we should really be able to point out our perfect squares by now. Square root of 36 is a perfect square, so that just becomes 6 over square root of 5, which is going to make our life easier when we go through to rationalize. So we multiply by the square root of 5 over square root of 5, and you get 6 square root of 5 over 5.